So let's discuss question number 52 and 53, which is again the linked data question, and this is from test 5. Okay, so at a point on a free surface of an aluminum alloy machine part, the measured strains are given. So at a point, well, always it's better to draw a element, and at a point you have this x, y, and the strains are given epsilon x, which is 825 micrometer per meter, and epsilon y, which is 950 micrometer per meter, and your 680 mu radians is your the tau xy, I mean the shear xy, okay, gamma xy. Okay, so now what is asked is the Young's modulus is given as 73 GPa and Poisson ratio is given as 0.33. So the stresses are asked. So if you remember the modified Hooke's law, if I have the stress here sigma x sigma y, so epsilon x is sigma x by E minus, because of the sigma y there will be a decrease in the strain, and that is because of the Poisson effect. So this is the stress, and epsilon y will be sigma x sigma y by E minus nu sigma x by E. So this is from the modified Hooke's law considering the Poisson effect as well, and the gamma xy will be 1 by g tau xy. So this is also quite straightforward. Now g we don't have, we had everything in terms of E and nu, so g can be written as E by 2 1 plus mu tau xy. So this becomes 2 into 1 plus nu by g tau xy. Okay, 2 by E 1 xy. So strains are given, we need to find out the stresses. So these two are simultaneous equations, and if I solve them, I mean for individual stresses, how will I solve them? Well, multiply, I need to just multiply nu minus nu on both sides and then add or plus, so multiply the first equation with Poisson ratio, so epsilon x nu, and add, so the sigma x and this term will get cancelled if I multiply with nu, and I will get sigma by E 1 minus nu square. So sigma y will be, your E by 1 minus nu square, and so basically you are adding this, so it will be nu times epsilon x plus sigma y. So sigma, this is your expression for sigma y, and sigma x similarly will be 1 minus nu square epsilon x plus nu times sigma y. So from these two simultaneous, so these are the equations which you get from modified law. Now only thing is strains are given, you have to get the expressions for stresses. So we get the expressions for sigma y and sigma x in stresses, and this is already, so tau xy in terms of gamma xy will be E by 2 1 plus nu, basically g into gamma xy. So these three are the expressions, we have to just plug in the values and find out. So if you plug in the values, sigma x would be, so let's take this equation, 73 GPa, so 73 into 10 power 9 by 1 minus 0.33 whole square, epsilon x is 825 plus nu is 0.33 950, so this is 10 power minus 6 micrometer. So this stress sigma x would come close, so if you just calculate, it comes to be 93.267 MPa. Okay, and similarly sigma y, if you have to just substitute 73.10 power 9 by 1 minus 0.33 whole square, nu times sigma x, so 0.33 of 825 plus 950 into 10 power minus 6. So this value, if you just calculate, this comes out to be 100.128 MPa. And from this tau xy expression, the tau xy will be 73 into 10 power 9 by 2 into 1 plus 0.33 into the gamma xy, which is in micro radians, so 680 mu, that is micro radians. That's how you measure the shear strain in radians. So this value comes out to be 18.66 MPa. So the answers are 93, 100, and so let's see the answer for, yeah, so it's all the first bit 93, 100 and 18.6. So the answer for the 52, so all this we did is 52 is A. Now 53rd is, once you get the stressors, that's why it's a linked data question. Once you get the stressors, what is asked is the principal stresses is asked. So you know the state of the stresses, you know sigma x, you know sigma xx, you know sigma yy, and you know tau xy, right? So these are the things which you found out in the first bit. Now maximum principal stress, which is a plane stress problem, so it is sigma xx plus sigma yy by 2 plus or minus for maximum or minimum sigma yy by whole square plus tau xy. So let's calculate this. Sigma xx is 93.267 plus 100.128 by 2. Let's take the plus for maximum, and then 93.267 minus 100.128 whole square, so bit of maths, plus 18.66 whole square. So this is the max principal stress, and if I calculate this value comes out to be 115.7 MPa. So this is just a straightforward, once you get the stresses, this is just a straightforward problem by taking plus. Okay, so the answer for this is, let's see where is the answer, 115.7. the answer is B for the 53rd. Thank you.